Hello, and welcome to Lesson 4. Today we'll be talking a lot about arithmetic. Some of it's going to be review, and maybe some of it will be new to you. So let's go ahead and get started. So first off, let's talk about numbers. In algebra, obviously, we will be dealing a lot with numbers. So a good place to start is to really ask ourselves, what is a number? All right? A number represents an idea. Sounds pretty rudimentary. It's an idea, okay? So think about way back when man didn't have numbers yet. He'd look up in a tree and he would say, oh, look at that, I see an apple, all right? And he would see this apple up in the tree. Well, if he wanted to express that, especially if he wanted to write that, he needed a way to represent that idea of one apple in a tree. And so he needed a symbol to represent that. And eventually, we choose the symbol 1. All right? That's the symbol that we use to represent this number of apples, or of anything for that matter. Okay? Now, what happens if there are 2 apples in the tree? Well, if there are 2 apples in the tree, well, then we need another symbol to represent 2. And it might be this. Okay? And so on and so forth. Maybe we eventually get to, 3 apples. Excuse my poor drawing of these apples. So if we have 4 apples, let's say, we need a number, a symbol to represent that. And it happens to look like this, a 4. Now, these might be the obvious symbols to represent these quantities of apples. But actually, there are many different symbols that we could use to represent these numbers. So for example, the 1. We could use a 1, as we've done, to represent 1 apple. But we could also represent that by 6 minus 5. That would be a legitimate way to represent a single apple. The symbols are different, but the idea is the same. Another way to do it might be to go 6 over 6. That would represent 1. For a 2, we could say it's 8 divided by 4. That represents 2. Or maybe 7 minus 5. Or maybe 1 plus 1. You can see that there are infinite ways that we could represent 2. Maybe it's, 100 divided by 50. Okay? Same thing, we could do the same thing with the 4. The bottom line is that we need to recognize that for any one count of something, there are infinite ways that we could represent that symbolically. And often what we are doing in algebra is taking a set of symbols, such as maybe this 8 divided by 4, and we try to simplify it. We try to rewrite it in symbols that make more sense to us. So if I say I have 8 divided by 4 apples, that doesn't make as much sense to most people as it would if you were to say I have 2 apples. 2 is obviously the best way to represent 2 apples that you see in a tree. Okay? So just kind of keep this in the back of your mind because we will be kind of branching off of this in later lessons. Numbers are symbols and that there are many symbols to represent the same idea. Okay? All right. Now let's talk about a couple of counting systems. So we use the decimal system, and the decimal system has 10 digits. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I know I'm not telling you anything you don't already know here. Okay? But we also have what's called natural or counting numbers. So when we think about natural or counting numbers, we're really thinking about any of the numbers that you would use to count something. All right? Now that might be kind of a trick question. Would you use the number 0 if you're going to count something? Well, the answer is no. If you're going to count something, we're going to assume that there is something to be counted. And if there is something to be counted, you're never going to use the number 0. Okay? It'll always be at least 1. So if at any point anyone, including this textbook, mentions natural numbers or counting numbers, in your head you have to think of these numbers: 1, 2, 3, 4, and so on and so forth. And I'm going to represent that by these 3 dots. It means it goes on forever in infinity in that direction, following this same pattern. All right, so essentially it's all of our whole numbers, positive whole numbers, and not including 0. Those are your natural or counting numbers. Now let's move on to another set of numbers, the positive real numbers. Okay, there's also the negative real numbers. The positive and the negative are both are 2 sides of the same coin. Okay, and that coin is the real numbers. So that's what we're really talking about here, are real numbers. And what are real numbers? Real numbers would be anything that could represent distances, physical distances, away from 0. And that might seem complicated at first, but let's just say that there are any kind of measurements greater than 0. So let's look at the positive numbers first. The positive real numbers would mean that if I have a 0, a positive real number is anything that is greater than a 0. It has to be greater than that. So maybe I'll just write this a little bit differently. So it could be a 1. A 1 is greater than 0. It is a physical distance away from 0. Notice I'm saying it's a physical distance. That means it's measurable. Okay, so if I say I have, I'm 1 inch away from the wall, that means that distance is measurable. It's 1 inch. Okay, so kind of think of the wall as being 0. Any place I can place myself that I can physically measure the distance between the wall and myself would be a positive real number. So 1/2 would also be a real number. That's a physical distance, or you could think of it as a physical distance. 0.6 is a physical distance. 3/4. Okay, all of these would be positive real numbers. Okay, what about negative real numbers? Well, negative real numbers is just the opposite. So negative real numbers means that we have a negative sign in front of them, which is kind of interesting because when you think about way back when man was learning how to count, he probably didn't think of negative numbers much because it's really hard to have negative apples in a tree. We already talked about he didn't like 0 too much. He definitely wouldn't have liked negative numbers. All right, so negative numbers do have some very important uses, but they are a little bit hard to imagine, in real life. What exactly does a negative number look like? Could you have negative of something? And the best way to think of it is just thinking of negative numbers as kind of numbers that you might owe. So for example, if you owe somebody $10, but you don't have it yet, you might think of yourself as being at negative $10. You don't have any money, and in fact, you owe money. So even if someone were to give you money, you still wouldn't have any money because you'd have to give it to the person you owe. All right? So you're in the hole. That's one way to think of it. Negative numbers, you're in the hole. All right? So what would be negative real numbers? Well, now it's the same thing as the positive real numbers, except for now we put a negative sign in front of it. So we have maybe a negative 1. Negative 1/2, negative 0.6, negative 3/4, negative 0.7896321. All right, all of these would be negative real numbers. All right, okay, very good. Now let's talk about the number line. This will help us to graphically envision what some of these negative and positive numbers look like. So let's take a look at a graphing line. So looking at this represents exactly that. It represents a graphing line or a number line, okay? And the way number lines work is we have a 0. That's at the middle of the number line. And because it's right at the middle, we have a special name for it. We call this point on the number line the origin, okay? The origin of the number line. And you can kind of think of that as the anchor of the number line. And then everything either goes this direction to the right, or it goes this direction to the left of this number line. Anything to the right is, of this origin. Anything to the right is positive. Anything to the left is negative. And this can be pretty useful because sometimes it's nice to know the distance between maybe a positive number and a negative number. And so if I think of, okay, well, if I've got a -4, what's the distance between a -4 and a 2? All right. The number line can be useful because we can count up the units. We have 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, 6 units. So there are 6 units between a -4 and a +2. All right. That's where that visual aid of the number line can be useful, but more on that later. Right now, let's just kind of understand how to set up a number line and just the basic details of it. The origin, and everything to the right is positive, everything to the left is negative. All right, moving on. This section, I'm not going to spend too much time on. Most of this you probably already know how to do. I hope most of this you already know how to do from previous lessons. They review it in the textbook, and if you have questions on how to do some of these problems, you can refer back to that textbook and look at how they did it in there and just refresh yourself. Because again, these things you should be able to know, or you should be able to do on your own already. All right. It's basically just simple arithmetic problems. So do you know how to multiply fractions? Do you know how to divide fractions? Remember, you have to take the reciprocal, right? So this becomes 5/7. We don't change the first one, but we take the reciprocal of the second one. We multiply it. I know this is divide, but we switch it to multiplication and take the reciprocal of this next one, which is 2/1. And by the way, I know I keep doing this, it's by habit. Here we have this dot that I've been using. That dot indicates multiplication. It's the same as this symbol, the X symbol. All right, the times symbol. So the times and the dot, they're the same thing. They're equal to each other. All right. Okay. So yeah. All right. Then moving on. Here you have more multiplication, and you need to remember how to cross cancel. So remember how that works. Looking at this multiplication problem, we can recognize that, 2 can go into itself once, 2 can go into a 6 3 times, and we can cross cancel that. 4 can go into itself once, 4 can go into 8 twice. We can cross cancel that. And then we can multiply the numerator, 1 times 1 is 1, and the denominator, 2 times 3, and we get 1/6. Okay. Here we have problems with mixed numbers. So we have a fraction part of a number along with a whole number. All right. And you need to remember how to convert these into improper fractions first before you multiply. Again, hopefully you remember how to do that. 2 times 2 is 2, plus 1 is 4. Or excuse me, 2 times 2 is 4, plus 1 is 5. We have 5 halves. Times 1 times 5 is 2 plus 2. 1 times 5 is 5 plus 2 is 7, 7/5. And then we could go ahead and cross cancel the 5s and we get 7 halves. All right. So hopefully you remember how to do all of these. This one over here may be a little bit different compared to what you're used to. We have kind of fractions within fractions, and we can do this in algebra. And one note I might just throw out there, the fraction sign, this bar, it always indicates division. All right, we usually think of these as fractions, but in algebra, we usually think of them as division signs. So this is the same thing as saying 1 divided by 2. We could read it as that or 1/2. All right, so here we have this big bar, and what we're really saying is the 1/2 divided by the 1/4. So this would be another way to write this would be 1/2 divided by 1/4. Okay. Excellent. So just very, very quick review on this stuff. Again, you should know this from previous lessons. And if you're at all unsure of yourself with these, please go back to the textbook, see their examples, and make sure that you're very, very comfortable with these before we move on to other lessons. All right. Next, we have some terminology to get through. So I've basically copied down all the terminology that they may throw at you throughout the textbook. This is a great page to pause the video and write these things down in your notebook so that you can memorize them for homework. All right? Make sure you know all of these, especially the ones that are in yellow. Those are very important. And actually, of those ones, I would say this one in particular is very important. Knowing what the word difference means. It's the answer to a subtraction problem. Sum is very important because you need to know that that is the answer to an addition problem. And then factor is huge. You need to know what a factor is. It's one of the numbers being used in a multiplication problem, and you need to know what product is. It's the answer to a multiplication problem. Those four, actually, you know what? I'm even going to say knowing the terminology for a fraction. The top number is the numerator. The bottom number is the denominator. The ones that I have circled in kind of this reddish color here, those are the most important. Make sure you've got these memorized because we will be using these terms, and when we do, I'm going to be expecting that you know what they mean. All right? Excellent. More arithmetic to review. So again, these are all processes that you should have learned in previous years. Just a quick refresher, when we're adding decimals, remember the most important thing is making sure that the decimals are in line with each other. So if I have these three things and I'm adding them together, I'm going to go 1.63 plus 0.62. I'm going to put that point right under the other decimal. 0.62. 12.7. This is crucial. I have to put the decimal point right below the other one. So 12.7 is going to look like this. Okay? I have to keep those decimals in line in order to add these. If it makes it easier, you can always tack on a 0 at the end of these decimal numbers so that everything kind of squares up. And then you can add these up. So 19, 3, 4, 14. Keep your decimals in line. 14.95. Okay? And then hopefully you remember how to do division with decimals. If we have a decimal in our divisor, we need to move this over all the way to the end of the number and then move this decimal the same number of places over. That's where our new decimal is going to go. And then from there, we just divide as usual. All right? Multiplication. Remember in multiplication, we multiply these numbers. Now here in multiplication, we do not need the decimals to be lined up. We only need that in addition or subtraction. So in multiplication, though, we just kind of ignore the decimals while we do the problem. And then at the very end, we have to count up all the places for the decimals. So this first factor had 2 decimal places. The second factor had 1 decimal place. So we have a grand total of 3 decimal places. So we're going to move that decimal, which is invisible right here. We're going to move that decimal place over to the left 3 places. So 1, 2, 3. That's where our decimal is going to go. All right. Again, this should be review. If you're struggling at all with this, go to the textbook and really hit home some of those practice problems in the lesson for today until you have this and you're very comfortable with it. All right, so now the last thing that I really want to get through today is unit multipliers. This is very important. We'll be working a lot with these in future lessons. So pay attention to this part in particular because this may be a little bit new for you too. The rest up to this point was probably somewhat of a review. All right, so unit multipliers. Sometimes in mathematics, we like to change the units from one unit to another. So here we have 12 feet, and I want to convert that to inches. So I'm going from 12 feet to inches. Now, this problem is extremely easy. You could probably do it in your head, but there is a process to it that we're going to use in algebra, and I want you to learn that process. So the first thing to think about is we're going to take this 12 feet, and we are going to multiply it. I'm going to use the dot symbol. Well, you know what? I'll keep it familiar to you. I'll use the multiplication symbol. So 12 feet. I want to multiply that by something. I don't know what that is yet. And eventually I want to get it so that it equals something, but I want that something to be in terms of inches. All right? That's kind of my setup here. I'm taking the first number or the first measurement and I'm multiplying it by something, and I want that to be converted into, in this case, inches. So the question is, what should I multiply 12 feet by? Now, I don't want to change the value of 12 feet. That really can't change. All right? So I don't want to multiply this by something like a 2, because now I'm at 24 feet, which I've really changed the value. I've changed it from my original 12 feet all the way up to 24 feet, which is nowhere near the same number. All right? So I don't want to change the value. So how can I multiply something by something so that it doesn't change the value? So for example, if I have a 3 and I tell you, I want you to multiply this 3 by something, but I don't want you to change the value. I want the value to stay the same. So I want the value to still remain a 3. What's that something that I could multiply this 3 by? Well, there's only one thing that'll work, and that is a 1, right? If I multiply the 3 by a 1, I won't change the value. It remains a 3. Now that sounds pretty silly, but it's very important. So remember what we talked about earlier. This 1 is just a number, and as a number, it is just an idea. It's a symbol representing an idea. And I remember we also said that there are many different symbols that you can use to represent the same idea. All right? So we're going to use that basic principle here. So if I throw a 1 in right here, that's not going to do me any good. 12 feet times 1 is not going to give me something in inches. It's just going to give me 12 feet, right? So I want some units here. And the goal is to get rid of this feet without changing the value. So we're going to use something that's called a unit multiplier. Okay? A unit multiplier is a fraction which equates to a 1. They all equate to a 1. All right? And these fractions have units in them. So an example of a unit multiplier might be 1 yard over 36 inches. Now look at that closely. 1 yard over 36 inches. It's a unit multiplier because it's in fraction form, and it has units, yards and inches. And it equates to 1. Do you see how it equates to 1? We have 1 yard over 36 inches. Well, 1 yard is exactly the same as 36 inches. They're just two different ways of expressing the same idea. It's the same length. If I give you 1 yard of string and I give someone else 36 inches of string, I gave you both the same length of string, right? So whenever you have a fraction where the numerator is exactly the same as the denominator, it always equates to 1. If I have a fraction that looks like this, 4 over 4, that's going to equate to a 1. A 9 over 9 is going to equate to a 1. Anything over itself will be 1. So 1 yard over itself, which is at 36 inches, it's just another way of representing itself, is going to be equal to a 1. Now that brings us back to this concept up here. If I take a 3 and I multiply it by 1, I get a 3. What if I were to express this 1 as a unit multiplier? All right, different symbol, same idea. The goal here is to eliminate this foot, this term, this unit, feet, and I want inches. So what unit multiplier could you think of that has feet and inches in it? This has yards and inches. What if I want feet and inches? Can you think of a unit multiplier that would have that? Well, how about 3 feet? Well, excuse me. Sorry. How about 1 foot over 12 inches? Now I've got feet and inches, which are the units that we're working with. and it's in the form of a unit multiplier. 1 foot is exactly the same as 12 inches. It's 1 over 1. This is just another way of writing 1. Another way that I could write this would be the opposite, 12 inches over 1 foot. That would also be 1. It's just flip-flopped. So these two unit multipliers would be good unit multipliers to replace this 1 with. Okay? But remember, we're trying to get rid of the feet. So if I think of this 12 feet as a fraction, how would I write it as a fraction? If I have any whole number, like a 7, and I asked you to write it as a fraction, what would you do? The easiest way would be just to write it over a 1, right? 7 over 1, that's equal to a 7. Same thing applies here. Write 12 feet as a fraction. Just put it over a 1. There, it's a fraction. All right? So if I write it as a fraction, and then I take this 1 and I erase this 1, and instead I put in there one of these unit multipliers that we came up with, which one would work better? All right? If I don't like this feet, because remember, I'm trying to get to inches. I don't like this foot. I'm going to multiply it by a unit multiplier. Where do I want that foot? Do I want it on the top or do I want it on the bottom? Top or bottom? And the answer is, in this particular case, I would like it on the bottom. Why would I like it on the bottom? Because as we said before, hopefully you remember how to do this, but when you're multiplying fractions, you can cross cancel. The same thing applies to units in a fraction. So these feet would cross each other out if they're on opposite sides of the fraction bar. All right? So therefore, the unit multiplier I'm going to use is going to be this one, the 12 inches over the 1 foot, because then the feet cross out, which is beautiful. I don't want the feet. And look at what happens. I end up with, when I multiply this out, I go 12 times 12, the numerators, 12 times 12, is 144 inches, which is what I wanted, over 1, which, of course, is just equal to 144 inches. There you go. I converted the 12 foot to inches. I got it as 144 inches. How did I do it? I used a unit multiplier. All right, so that's kind of a long explanation. Let's try another problem here and maybe go a little faster with it and see how you do. So if I have 72 inches and I'm trying to convert that into yards, we want to use unit multipliers. So we want to take 72 inches, and I'm going to write that as a fraction over 1. And I'm going to multiply that by something. I don't know what that is yet, but eventually I want that to equal something in terms of yards, because that's what we're trying to get to. All right, so here we have this empty space here for our product, or factor. What unit multiplier? Because remember, a unit multiplier just represents 1, so I'm not going to change, the value of this. I'm really just taking this and multiplying it by a 1, so I'm not changing the value, but I will lose the unit here, and the number may change. Okay, so what unit multipliers could we think of? If we're talking about inches and yards, the two that might come to mind would be, well, we could either put the inches over the yards, and if we do that, we would say, the 1 yard on the bottom, 36 inches on top, right? They have to, remember, they have to equate to a 1. So 36 inches over 1 yard would equal 1. Or I could do the flip of that, 1 yard over 36 inches. All right, now which one of these two should I use? What do you think? Well, I have the inches on top here, and I want to get rid of it. So I want to be able to cancel it out. So I want the inches on the bottom so that they will cancel. And so which one am I going to use? The one with the inches on the bottom. So I'm going to use the 1 yard over 36 inches. Okay, the inches are going to cross out, like we said. This will cross out with this. And then I have, some nasty numbers here, but we could reduce a little bit more. We could say, if you want to go with a 2 maybe, 2 can go into 36. 18 times. 2 can go into a 72 36 times. We could even go it again. 2 can go into 18, 9. 2 can go into 36, 18. 9 can go into itself once. 9 can go into 18 twice. I'm showing these basically so that we can see there's multiple ways to get to it. I could have just said 36 can go into itself once. 36 can go into 72 twice. All right, but if you didn't see that, you can certainly start with something smaller like a 2 and work your way down. All right, so eventually we get to this, and now we have 2 times 1 yard is going to be 2 yards over 1 times 1, which is just 1. And of course, that is going to be equal to 2 yards. So there we go. 72 inches is equal to 2 yards. All right? Okay. Very good. Why don't you try this one on your own, and then we'll try it together. All right, so you may have been hung up a little bit on this one because of the units being used. They have meters to centimeters. So now you need to remember some of your old measurements. How many centimeters are in a meter? Okay, but let's set this up like we did before. So we're given 42 meters. So I'm going to write that, 42 meters. I'm going to write that as a fraction. And I'm going to multiply that by something. And I want this to eventually get to centimeters. There we go. I have my setup here. Now I need to think about what unit multipliers I'm going to use. So I'm dealing with meters and centimeters. What do we know about those? Well, if I put meters on top, centimeters on bottom, how could I equate these so that they work out to be 1? Well, 1 meter is equal to 100 centimeters. So that would work. 1 meter over 100 centimeters is the same. It's going to be equal to a 1. Then I just flip it. 100 centimeters over 1 meter. So those are my 2 unit multipliers. Which one should I use? Remember what we did last time. We said, okay, I have a meter on the top. I want the meter on the bottom, so it cancels out. So I'm going to use this one. So I have 100 centimeters over the 1 meter. Okay, now it's just a matter of multiplying things out. 42, or actually, meters are going to cross out. 42 times 100 is going to be 4,200 centimeters. There it is. All right? Excellent. Let's go to this next one. We'll do it together because this one's a little bit different. This one is dealing with, it says use 2 unit multipliers. So don't let that throw you off. It just means there's a little bit more work. So we're trying to go from feet to centimeters. 42 feet. So I have 42 feet. Write it as a fraction. And I'm trying to multiply this by something and eventually get to centimeters. Now the issue here is you might not know how many centimeters are in a foot. We're dealing with we're mixing the metric with the English measurements here. So you might not know how many centimeters are in a foot. And to get to centimeters, you might have to start with something you do know. So you might say, well, I don't know how many centimeters are in a foot. You might remember how many centimeters are in an inch. And if you don't, memorize it because that's going to be one that's going to come up a lot. So 1 centimeter is the same thing as 2.54. Oh, I'm sorry. I have this backwards. 1 inch. 1 inch is equal to 2.54 centimeters. Okay? So that is one multiplier, unit multiplier. Another unit multiplier would be the reverse of that, or the flip of that. 2.54 centimeters is the same thing as 1 inch. Now, this does not get us from feet to centimeters. It actually gets us from inches to centimeters. So if we convert this to inches first, we could then convert the inches to the centimeters and get where we want. So we're going to use 2 unit multipliers. This is one set that we'll be choosing from, but there is going to have to be another set, and that other set is going to have to deal with the feet getting that to the inches. So we could use 1 foot over 12 inches, or 12 inches over 1 foot. That would be our other set of unit multipliers. So bottom line, we're going to take this 42 feet, multiply it by something to get to inches, and then take those inches and multiply it by something to get us to centimeters. All right? So if we're going from feet to inches first, we're going to use one of these green unit multipliers. So which one should we use? We want the foot in the bottom. So we're going to be using this one. 12 inches over 1 foot. Now, if you want to, you can even just cancel those feet out now so that you recognize that those cross cancel. And now you see that we have inches, but we're trying to get to centimeters. So now is where we go to our next unit multiplier. And we're going to say, well, we want to multiply this by another unit multiplier. We want inches in the bottom so that the inches cancel out. And so here we're going to use the second one again. 2.54 centimeters over 1 inch. And now we've got inches are going to cross out. And all of our units then have crossed out except for the centimeters, which is what we want. Okay, so now we end up with just multiplying this out. We have all ones in the denominator. So that kind of eliminates, just disappears. In the numerator, we have 42 times 12, right? Times 2.54. I'm going to give myself a little bit of room here. Times 2.54. I won't even multiply that out. I'll leave it just like that. It's not a nice representation. I could find a better, symbol to represent this quantity by multiplying this actually out, but that's just elementary. I'm going to leave it at that. That is how many centimeters we have. And you'll find that in your textbook, they often do the same thing. They usually write it as 42 in parentheses next to a 12, which means 42 times 12, next to a 2.54 centimeters. And that's fine. If you want to write your answer like that, I would accept that. And your book would too. All right? So hopefully this has made sense to you. I think probably the biggest thing that I want you to take away from this lesson is how to use unit multipliers. They will come up in later lessons and they become a little bit more complicated too. So make sure that you're able to do these. All right, we will stop here for today. But before we do, one last thing that maybe you could throw into your notebook, and that is all of these measurements. These measurements are common ones that you'll find in this textbook. And so having these memorized is going to make these conversions so much easier. So write these down in your textbook before you end, or in your notebook before you end this lesson, and make sure you study them for homework so that you have them memorized. All right, that concludes our lesson 4. I will see you in the next lesson.